So we've been letting our dialysis tubing soak. So I want to go ahead and point out the other items I have here. You also want to find just a bowl from your kitchen that you're going to submerge your dialysis tubing into. So I just chose this bowl. You want to find from your lab kit your ruler, because we're going to be making measurements in centimeters. Then you also you either need pancake syrup, which is what I had in my kitchen, so that's what I'm using, and I poured it into this measuring cup so that I could maybe perhaps use this little pour to pour it into my dialysis tubing. Now, Karo syrup actually works better than pancake syrup because it's a bit thicker, more concentrated, but this is what I had, so this is what I'm using, and it will work fine as well. So whatever you have. So these are the items that you want. You're also going to need like your phone maybe for a timer, because you're going to be timing from time 0 to 15 minutes, 30 minutes, and 45 minutes. So use your watch, use your kitchen timer, or whatever you have. So after you've let this soak, you're going to find it's become very flexible now. It's not nearly as stiff as it was. And you're going to use your thumb and forefinger like I'm doing right here. And it's going to open that tube. So you can see now that's actually a tube. And I'm at number 2 in your lab instructions. It says to go ahead and open it up and seal one end. So what I'm going to do is go ahead and take this in and make a knot. So I'm tying off these ends. Now, what I need to make sure and say to you, in the past when students have had any problems with this lab, it's because their knot was not very tight and they had leakage across that knot of the solution and it messed up their data. So you want to make sure that that knot is nice and tight, okay? So you're not going to have any leakage of the syrup across there. Okay, now once you've done this, then you're going to open the unsealed end, which is this end right here at the top, and you're going to pour syrup into your bag. So this is the tricky part, and this is the messy part, okay? So I'm opening up my bag here. So I just put some paper towels down to help with the mess a bit. But at any rate, what I'm going to attempt to do is to pour my syrup into this bag, and I want to fill it about halfway up. So I've opened up the end of my tube, taking my syrup with a little spout. I think that's the way to go. There we go. I'm gonna fill this up. Ugh, yeah, it's gonna be a bit messy, but we're gonna rinse it off, so it's okay. There we go. Ooh, okay, yeah. If I were a little bit more patient, maybe it wouldn't be so messy. There we go. Okay, so that's really plenty right there. That's good. And so it tells you now at number 4 to squeeze the air that's out of the top of this bag like this, and then knot the end. So now I'm going to do the same thing at the top. I'm going to knot the end of this bag. I'm going to rinse off my fingers there for a minute. And I want to make sure that it's nice and tight. Oops, sorry, back up a little bit. There we go. Okay. Now, after you've done this, you do want to rinse your bag off. And so I'm just going to dip it right back in here and rinse it so that we get any of the syrup that might have gone on the outside off of there. There. Now what we want to do is we want to measure it. So I got my bag a smidge full. I'm not going to lie, you should probably have a little bit less than that, but it's okay either way. We're still going to see what we need to see. But you're going to go ahead and measure with your ruler in centimeters the length of the syrup solution in your bag. So you're going to measure it. I've got about 9.5, about 9 centimeters of syrup. So I would take that value, 9 centimeters, and I would put it right here in table 1 at time 0. So I put 9 centimeters. That's the amount of syrup solution in centimeters that I have in my bag. Okay. Then after you've done that, you're going to place the bag into the bowl of water, all right? And you're going to let it sit. So you're going to start your time and make sure it's completely submerged. So get the end under there as well. So you're gonna let this sit for 15 minutes. After 15 minutes, you're gonna pull it out and you're gonna repeat what I did before. You're gonna measure. And so here's what we're looking for. The dialysis tubing itself, what we've done with this is we've simulated a living cell. So the dialysis tubing is simulating a plasma membrane or cell membrane. It's semi-permeable. So small materials can get across, water's a really small molecule. Big molecules can't get across. So it's really only selectively permeable in terms of size of the molecule. But it's gonna simulate the cell membrane for us again. And so what we're trying to determine when we put it in this solution is water gonna move into the bag towards the syrup solution, or is the syrup or any of the solution within the bag gonna move out into the bowl? So think about it for a minute. If I've submerged this for several minutes and I take it out, if my centimeter, if the amount of solution in here increases, then that means that water from the bowl moved into the dialysis bag. But if this solution decreases, if it gets smaller, that means that the solution in the bag has moved into the bowl. So, think about it. What would you predict? Remember, if you've gone back, if you've read this section in your textbook, or if you've listened to the PowerPoint that I had audio on for you, remember one of the things that I emphasize in the PowerPoint with audio is that in terms of osmosis, water follows salt. And that's a really simple saying to remember, and it really gives you a very good idea of being able to predict which way water's gonna move. Water follows salt. Salt is really just a solute. It doesn't really have to mean salt. It's just wherever the solute concentration is higher, that's the way water's gonna go. So water's gonna move towards a high solute concentration. So think about that, as you're looking at this experiment. And then the other terms you need to master the terms hypertonic, hypotonic, and isotonic. Those are tonicity terms that we use to describe solute concentrations. So remember, if you have a concentration that has a high solute, that term would be hypertonic, right? Hyper means greater solute. Hypotonic means a lower solute concentration. And isotonic means the same solute. So for example, if I had taken a dialysis tubing and if I had put water in it and then put it in a bowl of water, then those solutions would be isotonic because the solute concentration would be the same. But that's not what we have here, right? We have syrup, which remember is really super sugary and thick and sugary, and then we have water. So I don't want to give it away, but I want you to think about, which solution is hypertonic? Is the syrup hypertonic or is the water in the bowl hypertonic? Which one's hypotonic? Is the syrup hypo or is the water hypotonic? Okay, so those are some things to think about. I don't want to give away the ending because that's your job, is to go ahead and run this experiment, see what happens to the amount of solution in the bag. Make sure those knots are tight so you don't have any leakage across there. After you've done that, I'm going to go ahead and move these things. I want to show you the graph you're going to draw really quickly. So after you've taken your data at time, after 15 minutes, after 30 minutes, and after 45 minutes, you're going to graph the changes in the syrup solution amount over time. And you can graph it by hand using graph paper, or you can do it electronically. But here's what you want to remember. When you make your graph, it's going to be a line graph, by the way. So we're not having a bar graph. It's going to be a line graph. And on the x-axis, you want time in minutes. So I went ahead and put that on here, 0 time, 15 minutes, 30 minutes, 45 minutes. So your first reading is going to go at 0. And then you're going to have the size and the amount of the solution in your dialysis tubing in centimeters on the y-axis. So depending on your data, you'll need to figure out how you want to, how you want to spread out your numbers here. At any rate, from there, you're going to draw a line graph. So your line's either going to go, it's going to be up and it's going to go down, or it's going to be down and it's going to go up. indicating that either the syrup solution got greater over time because water moved into the bag, or it's going to indicate that the syrup solution decreased over time because the syrup solution left the bag. So we'll see what happens, but you want to go ahead and create a graph, and you want to upload that with your lab as well. Okay, thank you. Let me know if you have any questions.